This next case, you'll be told table 1 shows the masses in kilogram of 40 steel rods used in a mechanical show. So in this table, you'll be told these are the masses of 40 steel rods. Okay? Then you'll be told group the data in frequency distribution table using the classes of 0.6.0 to 6.4. Then 6.5 to 6.9. Hence, you determine the mean and the standard deviation. So the first thing we need is the what? The classes. For us to construct the frequency distribution table, we need the classes. So have the column for the classes. So the first class you'll be told to start from 6.0 to 6.4. Then the next class, 6.5 to 6.9. So from these two classes, you will be able to see that trend, isn't it? Meaning, if this one started from 6.0 to 6.4, this one 6.5 to 6.9, meaning the next one is going to be 7.0 to 7.4. This one is alternating with this, isn't it? Then this one was 6.5, meaning the other one is 7.5 to 7.9, isn't it? Then this one is now alternating, it's going to be 8 point, meaning if this one ended at 7.9, this one starts at 8.0, isn't it? Then it is moving to 0.4, see there? Meaning up to 8.4. Are we together? Meaning if you check the trend, there's 0.4 in between, but that is not class interval, it is just a trend you use, isn't it? 0.4. So if this one ended at 8.4, the other one started at 8.5. And it is ending at 8.9. Now, one thing you need to note, when you are doing this, you must have identified the highest data value. Because when I looked, I saw the highest data value was 9 point something. That's why I'm not bothered when I'm still moving. You see? Yes. So if you look at this first row, the highest data value there is 8.4, 8.7. Here we have the second row, the highest value there is 9.1, isn't it? Yes. The third row, the highest data value is 9.4. Here 8.8. So it means that the highest data value is what? 9.4. So it means the last class must capture 9.4. Stay there. So it means we are still proceeding, isn't it? The 9.4, the largest data value must be captured. The largest data value must be captured in a class. So if this one ended at 8.9, this one started at 9.0 and it ended at 9.4. See, if it ended at 9.4, it means 9.4, the largest data value has been captured into a class, isn't it? Yes. So that one becomes the last class, isn't it? Are we together? Yes. Now we need the frequencies. So for us to get the frequencies, we tally, isn't it? We tally the data to get the frequencies. So have the column for tallying to give us the frequencies. Are we together? Yes. So start tallying. You cross, then you count. So 6.6 is in which class? It's between 6.5 to 6.9, isn't it? Yes. So you count it there. Then the next one, 8.7 is in which class? It is between 8.5 to 8.9. You count it there. Remember, one stroke means you counted it, isn't it? Then you move to the next one, you cross. 7.9 is in which class? Between 7.5 to 7.9, isn't it? You count it there. You move to the next one. 7.4 is in which class? Between 7.0 to 7.4. So you count it there. Then the next one, 8.4 is in which class? It is between 8.0 to 8.4. You count it there. Then the next one, 7.2 is in which class? It is between 7.0 to 7.4. So there. You count it there. Then the next one, 8.1 is between 8.0 to 8.4, isn't it? You count it there. The next one, 7.8 is between 7.5 to 7.9, isn't it? You count it there. The next one, 6.8 is between 6.5 to 6.9. You count it there, isn't it? The next one, 7.4 is between 7.0 to 7. You count it there, isn't it? Then the next one, 7.1 between 7.0 to 7.4. Then you continue. 9.1 is between 9.1 one, 6.2 is between 6.0 to 6.4. So you must close whatever you counted. That is when you relax, you will know where you stopped counting, isn't it? Then you continue. 7.7 is between 7.5 to 7.9. You count it there, isn't it? Then 8.6 is between 8.5 to 8.9. You count it there. 8.7 is between 8.5 to 8.9. You count it there. 7.2 is between 7.0 to 7.4. So the fifth one you tie with to form a band. You see? The fifth one you tie with to form a band to make counting easier. I move on. 8 is between 8.0 to 8.4. You count it there, isn't it? Then the next one, 7.7 is between 7.5 to 7.9. You count it there. Then the next 8 is between 8.0 to 8. You count it there, isn't it? Then the next one, 7.6. It is between 7.5 to 7.9. So that's the fifth one. The fifth one you tie with, isn't it? Then you move on. 8.3 is between 8.0 to 8.4. That's the fifth one. You tie with, isn't it? Then 7.5 is between 7.5 to 7.9. You count it there. 7.1 is between 7.0 and 7.4. You count it there. Then 8.3 is between 8.0 to 8.4. Then the next 6.7 is between 6.5 to 6.9, isn't it? Then the next one, 9.4 is between 9.0 to 9.4. See there. Then the next one, 6.4 is between 6.0 to 6.4. Then the next one, 8.2 between 8.0 to 8.4. Then the next one, 7.8 is between 7.5 to 7.9. Then the next one, 7.7 is between 7.5 to 7.9. Then the next one, 6.7 is between 6.5 to 6.9. Then the next one, 7.6 is between 7.5 to 7.9. The next one, 8.2 is between 8.0 to 8.4. The next one, 7.8 is between 7.5 to 7. That is the fifth one you tie with, isn't it? So you move on. 8.8 is between 8.5 to 8.9. Then the next one, 6.6 is between 6.5 to 6.9. The fifth one you tie with, isn't it? You move on. 7.9 is between 7.5 to 7.9, isn't it? Then the next one, 7.4 is between 7.0 to 7.4, isn't it? Then the next one, 6.4 is between 6.0 to 6.4. So it means you counted everything, isn't it? So from the tallying, you are now able to see the frequencies, the number in each and every class, isn't it? So can you now count what you've tallied? Here you counted 3, isn't it? So it means that class there's a frequency of 3. Here you counted 5, isn't it? That class has a frequency of 5. Here you counted 5 plus 2, that is 7. In this class, 5 plus 5 plus 1, 11, isn't it? And in this class, 5 plus 3, 8, isn't it? And in this class, you counted 4. And in this class, you counted 2. So if you sum up all the frequencies, you are supposed to get the total number. And the total number you were told they were masses of 40 steel rods, isn't it? Yes. So, and the frequency giving you 40. Yes. So if it is 40, it means you counted everything, isn't it? Yes. So after frequencies, we now need X. The value denoting each and every beta value in a class, isn't it? Yes. Because we've been told to find the mean and standard deviation, meaning we need a value representing each and every class. So X are the midpoints, isn't it? Yes. X are the midpoint. So what is the midpoint of 6.0 to 6.4? The midpoint there is 6.2, isn't it? The midpoint of 6.5 to 6.9? 6.7. Just look for the average, isn't it? The midpoint of 7.0 to 7.4? 7.2. You go to the next, the midpoint between 7.5 to 7.9 is 7.7. Then you move again, the midpoint between 8.0 to 8.4? 8.2. 8.2. You move again, the midpoint between 8.5 to 8.9? 8.7. 8.7. Then the midpoint between 9.0 to 9.4? 9.2. So because we are going to get to the mean, we must have a column of f of fx, isn't it? So we need a column of fx because we've been told to find the mean, isn't it? So fx, it means f times x, isn't it? So 3 times 6.2, you get 18.6. You move again. 5 times 6.7, you get 30? 33.5. Then the next one, 7 times 7.2? 50.4. Then the next one, 11 times 7.7? 84.7. Then the next one, 8 times 8.2? 65.6, isn't it? Then the next one, 4 times 8.7? 34.8. 34.8. Then the next one, 2 times 9.2? 18.4. Are we together? Good. So fx squared, because we've been told to look for the standard deviation, meaning we are going to get the variance. So we need a column of fx squared, isn't it? Fx squared is fx times x, isn't it? So fx times x gives you fx squared. So start with the first one, 6.2 times 18.6. 115.32. Then the next one, 6.7 times 33.5. 224.45, isn't it? Then the next one, 7.2 times 50.4. 362.88. Then the next one, 7.7 times 84.7. 652.19. Then the next one, 8.2 times 65.6. 537.92, isn't it? Then the next one, 8.7 times 34.8. 302.76, isn't it? Then the next one, 9.2 times 18.4. 169.28. So we've gotten all the fx squared. Now what do we need? We need to add up all fx, isn't it? We need to add up all fx. So what do you get if you sum up all fx? If you sum up all fx, what do you get? Can you add them up? If you sum up all fx, what do you get? Add all the fx. Three or six? 306.00. So it is just 306. Yes, then the next one, we need to sum up all the fx squared, isn't it? So can you sum up all the fx squared? What do you get if you sum up all the fx squared? Sum up all the fx squared. What do we get? 20? 2364.8.80. That's just 2364.8.8, isn't it? Now, the first thing we've been told to determine is the mean, meaning those are the only columns we need, isn't it? The column of fx will help us get the mean. The column of fx squared will now help us get the standard deviation. This is the standard deviation by getting the variance, isn't it? Are we together? So start by answering the first part, mean. The mean is given by summing up all fx and dividing by that total number. Meaning the mean is summation fx divided by summation f, isn't it? Are we together? Summation fx divided by summation f, this divided by this, you get the mean. That is 306 divided by 40. What is the mean? 7.65. You are done with the mean, isn't it? Then the next we need is the standard deviation, meaning we need to get the variance first, isn't it? So the variance is going to be, the variance of x is going to be the mean of x squared, which is this summation fx squared, isn't it? Summation fx squared divided by their total number, meaning summation fx squared divided by summation f, isn't it? Are we together? Then it is minus the mean squared, isn't it? Minus the mean squared, the mean of x squared. The mean of x you can just write as x bar, or it is this squared, still the same thing, isn't it? Can we now substitute to get the variance? Summation fx squared, you found it to be what? 2364.8. We found it to be 2364.8. Then their total number, summation f was what? Was 40. Then it is minus the mean squared. And you already found the mean to be what? 7.65. Then that mean is squared, isn't it? So if you work out this in the calculator, what do you get with the variance of x? 0.98. Just like that. You rounded it off. Who put it to four significant figures?
0.59.
It is not 0.98. 0.59? 75. You get 0.59775. Are we together? Now that is the variance. But what do they want? The standard deviation. So you know the standard deviation is the square root of the variance. So what do you get with the answer? Square root of 0.5975. Then you get the standard deviation to be 0.773, isn't it? So that is how to determine the mean and standard deviation after constructing the frequency distribution table. Are we together? Good.